Thanks, everyone. It's a pleasure to be here. My name is Paolo Faraboschi, and as the slide says, I actually lead a group of researchers in Hewlett-Packard Labs, which is the organization that's doing advanced development and research at Hewlett-Packard Enterprise. And I'm here to talk to you about things that people don't normally tell you about language models and the risk associated to that, the evolution of how we got to where we got to. What are the principles we've developed to kind of make the models behave in applications that are critical in the enterprise, and then some of the technologies that we've been developing in labs to help evaluate, refine, recommend models, and kind of help people kind of reason around the big variety of options that are out there, and give you some examples that you can also find on the showcase floor in case you want to follow up with that. So, typically, if you're in an enterprise right now, everybody in the enterprise is thinking about how am I going to deploy AI in my use cases. If once I've identified a use case, which model should I pick? Should I just use a cloud-based API? Should I go with one of the open source models? Are these enough for me? Are these models production ready? What else is necessary around it to build it? What about the governance that I need to put in place? Is there anything that I need to think about? How am I going to use the model? What kind of risk am I exposing my operations using that model? And what do I need to get started? And hopefully, at the end of this talk, you'll get some ideas of what are the challenges, what are some of the technologies. Some are still in research, so they're not something you can adopt tomorrow, but we welcome anything that we can talk to us, and certainly we can advance the field. And if you heard Antonio's keynote yesterday, he also went through some of the principles that we use internally within HPE to assess AI projects, even for our own internal use. I actually co-chair our AI ethics committee. And in the last 2 years, we have seen an enormous surge of new projects. I mean, 2 years ago, 3 years ago, they were like, once a month. Now we're getting like 100 a month of use cases that people submit to take a look at. And we're looking at these things through a lens of these 5 principles that are trying to assess whether a model application of AI is, for example, privacy-enabled and secure. You want to make sure that the data that you feed to train AI or that you use in the operation and deployment of AI doesn't leak, that you have no risk or you limit your risk depending on the kind of data, again, you're using to train it, especially if you're in a regulated industry, and that's very important. You want it to be human-focused. This is the fundamental principles of AI requiring a human in the loop when you're in a decision process. So you don't want AI usually to take an autonomous decision, especially in mission-critical application, without a human in the loop. So AI is becoming a lot more like an assistant that gives you a set of options that then a human needs to pick and has the ultimate responsibility. Inclusivity is all about bias, right? So you want to make sure that, for example, and I'll talk about that in an example in the financial services, that if you're using certain data sets to train your models, you understand the statistical property so that you know in what dimensions these are biased, and you're making sure that those models are inclusive of the type of behavior that you want to capture. You also want them to be responsible. And responsibility is a lot about being able to explain what a model does, especially when a model makes the wrong decision. Then you want to be able to trace back of what was the cause of that decision, whether it goes back to all the way to the training, and then perhaps fix it by providing additional training samples, or perhaps making sure you put the right guardrails around the decision. And finally, something that we think is very important and often is also overlooked is the robustness of a model. Have I built the model in a way that I understand where it breaks? Because everything is going to break. There's no model that is perfect. And I'll even show you kind of an interesting example in a second. It will break. The question is, do I know how fragile it is depending on the application? Can I quantify it? Can I engineer it so that I understand the robustness? First thing is you got to measure it, and then you can try to fix it. So in labs, we have several research projects around, this area of what we call responsible and trustworthy AI. We're looking at ways, and I'll talk a lot about that, on how we design and synthesize the model for trust. We actually started this work 5 years ago when we had no generative AI, so most of the work initially was designed for classifiers on computer vision, and I'll give you a quick example of that. And so, we want to design the model to be trustworthy. We want to understand and measure trust. And we also want to pay attention to the data layer because, as you know, the data is what fuels AI. And so, the way in which you process the pipeline, you want to be able to go back and version the data. We've built several platforms around that. So when I said an example of what we did a few years ago, this is a classification of the image. You can imagine we're using animals here, but if you're, for example, in the manufacturing industry, you can think of this being, a camera operation that, spots defects in whatever you're making, whether it's a chip or foods or anything like that. And you'll see that what we're doing here, for example, it's kind of hard to see from the screen, but the little box on the right that almost looks, on the bottom right, that looks dark with a few pixels is actually some noise that we're adding to the image through another AI engine that tries to find the smallest amount of noise you need to put to the image to make it, to break the classification. So in this case, you see that there's only a few pixels, right? That changes the classifier that you saw from a wildcat to a cougar, right? That basically, the model was designed to and trained on a set of images, but you only need to add those, handful, like 13 measure distance, pixels to actually make it break. So this model is brittle, right? Imagine that, this could be dust or, water, drops of rain or anything in your sensor that can cause the model to break and misclassify, and then depending on your application have severe or not consequences. Now, so what we've done is effectively we're using machine learning and AI to enhance AI. So the first thing we've done here, we built this smart agent that tries to find, the minimum amount of noise to break an image. And you can even design the type of noise. And, the idea is that we should be able to measure these things, right? Not just, cross your finger and hope it works. And that's sort of the work we've been doing here. And so we detect the vulnerable classes of all the things you're classifying, and you actually give you a number that says your model is vulnerable. But we can do better than that. We can actually use that same technique to generate synthetic data, feed it back to the training set, and hopefully produce a more robust model. And in the case of computer vision, we've done the same on this model. We've now closed the loop, generated a bunch of new synthetic images, and now this enables us to have a model that will still break if you change it enough pixels, but it will take a lot longer and a lot more noise that is unlikely perhaps to find in a real situation to actually break it. And when this ends, you'll see that, compare before we had the distance was like 13, now we have a distance of like 30 something, which means this model is like about 3 times more robust than the other model, right? So this was the kind of work we've done a few years ago in the field of computer vision. But as you'll see, we're using similar type of technologies sort of in the new domain. Now, since a few years ago, the world has changed, right? So in these days, we're talking about effectively a task-specific AI model that was just trained on labeled data. So since then, the world of AI has really boomed around unsupervised training, which means the models that most people refer to as foundation model, large language model, which are effectively trained once or a few times, but on an enormous corpus of unlabeled data. They try to find the correlation and create structure around unlabeled data. So they're, in a certain sense, harder to understand than some of the classifiers. So we had to adjust many of the techniques we've developed to kind of fit into the new world. And right now, again, we're not talking about, this is the pyramid of sort of AI classification use cases that we normally explain users of where they fit in the pyramid, starting from there's very, very few folks at the top that can design a new model, right? There's probably a handful of institutions and companies out there that could build a new transformer. Then there's a few more, but not many more, given the cost of training that can actually pre-train a new model. And then, at the other extreme, we got a lot of people that can use out-of-the-box models from, some of the popular models out there. What I'm going to concentrate is the big opportunity in the middle, where, you're an enterprise, you have a use case you've identified. Now you got to pick a model, you want to fine-tune it, you want to engineering the prompt system, you want to perhaps chain a few things together to fit your specific use cases, right? So that's kind of the typical deployment pattern that I'm going to focus on. I'm not thinking about, you're going to design a new, GPT or whatever it is, and I'm not just going to use something out of the box. I'm thinking that, the most interesting part is actually in the middle. Now, I'm not going to spend too much time here, but there's lots of use cases for foundation models. Most of them are about content generation. They're about, assistance. They're about, retrieval augmented generation, basically parsing all your documentation, being able to ask questions about it, personalizing, recommender, and so on. But also, another dimension that has recently emerged is the fact that there's a whole movement in the open community to generate open models. And now when people talk about open models, there are really two classes of them. There's like the open source model where people have published the code in repository like Hugging Face or so on. And then there's the open weight models of companies, for example, like Meta, who have trained the Llama family of models, and they're making available the trained version with the open weights. So you can actually use the trained version of the model. And if you look at the evolution over time, in this case, you're seeing kind of time on the X dimension and quality on the Y dimension, the open models that become really, really good. They're not quite there yet compared to some of the closed proprietary models, but they're getting better over time. So there are a lot of users that are thinking, well, perhaps I can start using some of the open models, the advantage being typically the cost and the fact that I can flexibly change them, as opposed to use some of the closed models where I don't know how they were trained and I kind of have to follow the way in which the model owner decides how am I going to consume it, right? What is the challenge here? Is that if you go to Hugging Face today, there are over 2 million models. It's actually true. And of those 2 million, there's probably about 100,000 models that are variants of language models, right? So now you got to hire your assistant, and you got 100,000 resumes to sort through, right? So what we're trying to do is give you an idea of how you can actually sort through these models and pick the one that's best for the job you're trying to do. The other complication is that bigger is not always better, right? Even the bigger models, they're not always completely reliable. Here's an experiment that I did on a popular generative AI model. I'm asking the model to generate an image of a room with no elephants, with less than one elephant, right? And this is what the model gives me. Then I said, well, not quite there, try again. I really want a room with no elephant. And the second time, and this is actually a session I recorded, well, still an elephant there. And then I said, look, there's something there that I don't want to see. And the model thinks about it and now gives me 2 elephants, right? So this is a very simple prompt, right? A 5-year-old understands the notion of a room with no elephants, right? The problem is that the attention mechanism focuses, that's the base of transformer models, is that this is the syndrome of don't press the red button. The first thing you're going to think about, there's a red button, right? So the transformer model is going to focus the attention on the word elephant. There's negatives are hard to map. And in this case, if you try 10 times, and you can try it yourself, you'll see that perhaps a couple of times is going to get it right. But what I'm trying to give you as a sense is that imagine translating this into an application that requires some critical thinking and does not actually, where a mistake is important and causes a bad behavior, then this is clearly not acceptable. So models, even the big ones, this is a 500 billion parameter model. don't always get it right. And so you always have to think about, what am I going to do to make this model fit into my application? And sometimes bigger is not better. You need to do something else. And I'm going to give you some ideas of what are the issues. Sometimes it's even how you phrase the prompt and whatever context you put around the prompt. And sometimes, there's other side effects, like you can show bias, you can show toxicity that sort of escape your typical prompting. So let's say, I'm going to walk through some examples. I want to create an application that's based on language models that, the job of the application is to give me an assessment of a loan, application from a user, right? So I'm a financial institution. I got some user requesting a car loan. They're going to send a bunch of documents and fill a bunch of forms. And I want to have an LLM that gives me a recommendation. This is a good loan, a bad loan, or think about it, and so on and so forth. I mean, the first thing I'm going to do is pick a model, right? And, I have different, parameters in terms of how much I'm willing to spend for the model, in terms of deployment and things like that. I got a bunch of models, thousands of models I can pick from. And then I want to try to find the one that fits this domain, and I'm going to try to figure out how to actually put it together. So is the model relevant? Is it good for this particular use case? What are the things I care about? What are the things I don't care about? Is there any hardware requirement? And how do I quantify risk, right? So this is sort of the problem I'm trying to solve, and which I think many of you are probably, or many of your application and line of business are thinking about today. I have an application use case. I think I got the data, and now what do I do? What models do I pick? Where do I start, right? So we put together this pipeline that is effectively a recommendation, an evaluation, and then a refinement. So in other words, you first want to sort of have a recommender that tells you, based on the way in which you evaluate the models, here are the top 5, or ranked in some order that you can pick from. Remember, human in the loop. I'm not going to give you one model and give you a choice, and then you can pick. But then also going to give you a technique that combines multiple inferences in a way that it will refine the output of the model to actually try to achieve and compensate for some issues. And if you think about it, going back to the analogy of I got 1,000 candidates, I'm hiring an assistant. The way in which we're doing it is what everybody would do in that position, which is, okay, the first thing I do is I look to the resumes. That's the evaluation part, right? And depending on the type of assistant, I'm going to focus more on one particular aspect of the application versus another one. So if I'm hiring an assistant that needs to be an expert at using Excel or some other math thing, I'm going to look for those kind of skills. And similarly here, we have a bunch of benchmarks, and based on the use case, we'll select the benchmarks, right? So that'll give us an evaluation. The second thing is, well, now I actually want to bring in the candidates and have an on-site interview. So now I'm designing a set of benchmarks and questions that I'm going to ask the models to actually have them, really try to be evaluated on the things I care about. Again, it's the moral equivalent of an on-site interview. Now, once I've hired my assistant, then I want to do specific training of the assistant to understand, the practices that I'm using in my company. And this is the similar thing for the model. Now I want to refine it so that, it will actually follow some of the rules that I've put in place, right? So these 3 stages are exactly the 3 stages that, you're thinking that you're effective. What you're doing is you're hiring an AI assistant here. You have to pick the model, you got to interview it, and then you got to kind of reinforce the training so that, you get the model with the right thing. So again, it's something that people think about naturally, but of course, there's a lot of technology behind each of these steps that you need to put in place to be able to do this magically. So example, I'm not going to spend too much time. The typical loan status would be, hey, give me the status of the loan based on the record, respond with good, bad, average, and then the prompt will be, okay, the neighborhood, the race, the gender of the applicant, the location, the age, the whatever, all the parameters you put in a loan, and the output would be, the loan is good, the loan is risky, and then some explanation. Well, the loan is, the credit scores are good, the demographics are risky, blah, blah, blah. So that's the kind of application you want. Then you pass it to an analyst. The analyst will quickly go and figure out what to do. So the evaluation of the models, of course, we're using the benchmarks. I'm not going to spend too much time on this one, but you get the idea. We're ranking the models. So there's a whole ranking system behind it that tries to quantify in numbers or in kind of qualitative assessment, things like cost, accuracy, explainability, fairness, and so on and so forth. And here, if you look at, for example, the benchmarks the models that we've looked at, you see small models, medium models, and like huge, API-based models in the cloud. And you just look at the overall score, you'll see that, some of the bigger models are not necessarily better for this kind of application that we're putting together. The best model was actually an 8 billion model that was designed for the mortgage application, right? Which is probably not surprising, but in this particular case, the system did, surface it and bubbled it to the top. And similarly, there's like a financial LM and other things I don't know. Those would be good choices because they're low cost, they're targeted for this use case, and then I can create, the system around it to improve it. Now, again, if I'm using the same prompt as before, here the kind of difference is, like the big model would tell me that the loan status is bad, but if I look at it, it's actually using things that I don't want, because it's saying, well, because there's debt consolidation, and so the applicant is trying to kind of pull out, request more money. But actually, some of these are good things, and say, well, the credit score is too low, but that's actually not bad. It's missing the context, right? And some of the good model, like the one that I said before, the 7 billion, actually focuses on the things that matter here, like the last payment, the consolidation is actually good, is a good behavior, and then you're not emphasizing certain things. So it's injecting a context of the domain. And remember, these are like models that were trained on the whole internet, right? They don't understand what a loan is. It's just that that's how the transformer thinks. But you can actually force it to go in certain direction by making sure you fine-tune it in certain ways. And so the explainability of these models sometimes is where things can go badly wrong, right? So for example, in this particular case, we're putting emphasis on the decision on things like neighborhood or race, or things that you're not supposed to do because it violates some of the fairness principles, some of even legal restrictions, right? So you want to make sure you put in the refinement that tries to steer the model to make sure that I cannot use race as a discriminant. I cannot use neighborhood either, because neighborhood leaks the bias into race, even if you don't know. And so these are some of the things that you want the model to fix, right? So what we're doing to fix these things, we're creating this system, which is effectively a combination of different models. We call it an ensemble of AI critics. So rather than having the model just give me an answer, we're feeding the output of a model to another set of smaller models that act as reviewers, judges, or critics, however you want to call it, right? Which is typically, if you think about yourself, what you would do when you produce some text or something, you do normally two things. One is you read it again, so it's self-reflection, and you give it to a bunch of reviewers or friends who read it and tell you, yeah, well, this isn't quite right. So we're doing the same thing here. So these critics are designed with a collection of targeted prompts to spot certain behavior that are undesired, like bias, like fairness, like the things that we capture in the principles. Now, these critics are another language models. We use multiple of them for diversity because each of them is designed to spot a different misbehavior. Then effectively what they do is they feed back the prompt to the language models again. And they're saying, well, the answer was not exactly what I thought because you're looking at gender, you're looking at race or whatever, so don't do that, right? And so the models next time around is likely gonna produce a better answer, and actually it works. So what we're doing in reality is trading the complexity of multiple inferences against bigger models, right? And that's the direction that a lot of the community is going. There's a perception that through multiple inferences, you can get a much better chain of thoughts, much better quality than just by making a model bigger and bigger, except that now you need special knowledge to create this kind of chain of thought depending on your specific domain, right? So the world is evolving. The world of language model is becoming a lot more complex, but there's a clear set of technologies that can help you, for example, manage your costs, get better quality without going for brute force size, right? And I can fast forward a little bit, but this is the kind of feedback that the critic will give you, right? In this case, the critic one, it will tell you, look, you shouldn't be weighing the gender. The neighborhood is wrong. The key consideration are that what you told me violates the Fair Lending Act, so you can't use that. You're missing explainability for some of your decisions. Your contextual evaluation is missing the fact that some of the parameters are actually good. And so once you put all of these together, then the final output actually looks much better. If we have different scoring mechanism, the raw output would be the first one, then the 2 critics or 3 critics give you the feedback, then in one step I'm getting to a better output. Or I can do a few more iterations and pay a bit more in inference, but something like that. Of course, we're putting things together in a more complex workflow where it's not just as I described, this is not manual, there's a complex workflow where effectively I have language models, I have how I break the problem into this chain of thought complexity, how I actually inject the specific knowledge or the misbehavior that I want to capture through what is called in-context learning. So I create a special prompt for the critic that will create another input, and then I need to put in a bunch of guardrails to make sure that people aren't trying to kind of find ways around it, and so on and so forth. And so when I'm doing this, I'm creating this workflow, and of course, we're measuring things, and we're getting better results at the end, right? So, I kind of hope that I gave you an idea of the evolution and complexity of the AI world, especially when it comes to the application of large language model to critical problems, right? So, for example, the fact that it's very important to understand how the governance system is you build around your generative AI models. As we say, we joke, evaluation is the new training. You cannot possibly afford to exhaustively evaluate thousands of models on every benchmark. It will cost you more than train a new model. So you got to find techniques that effectively scale down the evaluation and use this 3-stage process. Remember, kind of hiring your assistant in a way that is more structured. Bigger is not always better, and no matter how big it is, even the biggest model out there will miss the elephant in the room. If there's something to remember is that even the biggest and most powerful model will miss the elephant in the room unless they're guided in the right place. And there's hope, right? There's advanced machine learning techniques that are effectively combine multiple LLMs in a careful way using machine learning to effectively try to guide in a similar way in which we did for computer vision. We can do the same thing for generative AI and effectively get you a lower risk and a good quality. With that one, I think I've exhausted my time. There's a bunch of demos that I would encourage you to come see it in the show floor. We got some actual, real demo of the examples that I just talked about on the loan assessment. And I thank you for your attention and encourage you again